Imagine waking up on the moon, looking out your window, and seeing Earth floating in the sky. No longer just science fiction, lunar living is becoming a real possibility. Civil engineers, those who build our cities, are now designing the first human homes on another world. Why build on the moon? It's a launch pad for deeper space exploration and a symbol of human achievement. A lunar base lets us practice living off-world, use local resources, and push the boundaries of what's possible. Civil engineers are drawing up blueprints, testing materials, and planning habitats that could soon dot the moon's surface. The same ingenuity that built our cities is now aimed at the stars. The age of lunar construction is here, and it's one of humanity's greatest engineering challenges. Next time you see the moon, remember it could soon be home. The future of space living is being built right now. Building on the moon is nothing like building on Earth. Temperatures swing from boiling hot to freezing cold. Structures must survive both extremes. The moon's gravity is weak, and there's no atmosphere. No air, no pressure, no protection. Homes must be airtight fortresses, shielding people from radiation and micrometeoroids. There are no forests or steel mills. Every building material must be shipped from Earth at enormous cost, or found on the moon itself. Civil engineers must get creative using what's available on the lunar surface. This approach, called in situ resource utilization, is the only way to make lunar living practical. Every design must solve for safety, strength, and survival in a place that's utterly alien. The moon is a builder's ultimate test. But with innovation, these challenges are being met. Lunar construction is about turning the impossible into reality. The blueprint for life beyond Earth starts here. The moon's surface is covered in regolith, a fine gray dust once seen as a nuisance. Now, it's the key to building lunar homes. Engineers are developing 3D printers that melt and shape regolith into strong, ceramic-like structures. Robots could print entire habitats before humans even arrive, making missions safer and more efficient. Thick regolith walls protect against radiation, temperature swings, and micrometeoroids. Using local materials means less cargo from Earth and more sustainable living. NASA and others are already testing these technologies. The moon's dust is becoming the foundation for our future homes. With regolith, we turn a problem into a solution. The ground beneath our feet becomes our shelter. Lunar homes aren't boxes. They're domes designed to hold in air and withstand the vacuum outside. Dome shapes distribute pressure evenly, making them strong and safe. Walls are multi-layered. Tough regolith outside, insulation within, all to keep temperature stable and block radiation. Inside, life support systems recycle air and water, creating a tiny, self-sustaining world. Oxygen is made from water, carbon dioxide is scrubbed, and every drop of water is reused. Engineers plan to harvest ice from lunar craters, but nothing is wasted. These closed-loop systems are essential for survival. Every detail is engineered for safety, comfort, and efficiency. Building on the moon means building a world within walls. It's not just a house, it's a lifeline. The future of living in space depends on these innovations. This isn't distant science fiction. Lunar construction is happening now. NASA's Artemis program and private companies are racing to build the first moon base. Civil engineers are at the heart of these missions, solving problems and designing habitats. 3D printing companies like Icon are working with NASA to make lunar homes a reality. The skills used to build cities on Earth are launching us into space. STEM fields are where the next generation of lunar builders will come from. The dream of a moon village is becoming an engineering project. Soon we may look up and see the lights of human homes on the moon. The future of space living is in our hands.